Our last section was all about some of the basic trig identities. Those you're going to have to memorize. The sum difference formulas you do not have to memorize. They are called addition and subtraction formulas on this formula sheet that you will get for every test. So you do not have to memorize these. You just have to recognize when you're going to need to use them and be able to use them. So our learning objective for this section is to use the sum and difference formulas to determine exact values and to verify identities. So 7.2, this is addition, subtraction, or sum difference formulas. Sum difference formulas. And LO, I think by now you know, means learning objectives. We're going to determine exact values. And we're going to verify identities. So here's the intro. Does sine of A plus B, in parentheses, equal the sine of A plus the sine of B? So we test it out and we see that in fact it does not. It's not that simple. You have to use the sum formula. So I'm not going to derive them for you, and you don't have to memorize them, so life is good. But here they are. So we'll start with some examples determining exact values. And probably the most challenging part of determining the exact values is going to be figuring out how to get that number that you want. So the first one's easy. You have pi over 3 minus pi over 4. But what if you had just pi over 12? Then you would have to figure out for yourself that it's pi over 3 minus pi over 4. But let's jump right in and do some. Example 1. We have cosine pi over 3 minus pi over 4. So I'm going to pull out my little sheet here and have it readily available. I need a cosine, and it's cosine of A minus B. So that means this is going to be equal to cosine of A, cosine of pi over 3, times cosine of B, cosine of pi over 4, plus sine of pi over 3, sine of pi over 4. And let me make this a little narrower. There we go. So, cosine of pi over 3 is 1/2. Cosine of pi over 4, square root of 2 over 2. Sine of pi over 3, well, has 3 in the denominator, so it's square root of 3 over 2. And 4 in the denominator, everybody, square root of 2 over 2, sine and cosine. So we have square root of 2 over 4 plus square root of 6 over 4, and that should be square root of 2 over 2, not square root over square root. So I have square root of 2 plus square root of 6 over 4, and yeah, I would expect you to be able to combine it into one unit like that. Let's look at the next one. We have cosine of 75 degrees. So this is where you're going to have to use your imagination to figure out how you can get 75 degrees from two numbers that you know the cosine of 75 degrees would be equal to the cosine of 45 plus 30 degrees, because 45 plus 30 is 75. And we know cosine of 45 degrees, we know cosine of 30 degrees. So this time we're looking at a sum. So it would be cosine of 45 degrees, cosine of 30 degrees, minus sine of 45 degrees, sine of 30 degrees. And I have this backwards. No, I don't. I have that correct. It would be pi over 6. Then cosine would be square root of 3 over 2. Yeah. Okay. So cosine of 45 degrees is square root of 2 over 2. This one is square root of 3 over 2. Because 30 degrees is the same as pi over 6. I got it now. Sine of 45 degrees, square root of 2 over 2, and sine 1/2. So this time we get square root of 6, and I'm going to go ahead and combine it into one unit because we have a common denominator already. Tangent of 15 degrees. Now we have to think about how can we get 15 degrees. Well, I could do 45 degrees minus 30 degrees. So 45 minus 30 gives me the 15 that I want. So tangent, and it's a minus, so I'm over here. So it's equal to the tangent of 45 minus the tangent of 30 divided by 1 plus the product. Tangent of 45 degrees, that's my favorite because it's 1. Tangent of 30 degrees, well, 30 degrees is pi over 6, so that means cosine is on top. So, that means cosine gets the square root of 3 over 2, so it's 1 over square root of 3 because it's 1/2 over square root of 3 over 2. The halves cancel, and you're left with 1 minus 1 over the square root of 3. Then 1 plus 1 times 1 over square root of 3. So I would just multiply numerator and denominator by square root of 3. I get square root of 3 minus 1 over square root of 3 plus 1. And while I don't want a improper fraction, I don't mind a radical in the denominator. I'm going to pause and turn my page over. Now part D is a little different. Instead of giving us one term, it gives us what looks like the right-hand side of our formula. So I have to find one that has sine times cosine, cosine times sine, with a plus in the middle. So sine, cosine, plus cosine, sine. So this one is sine of 25 degrees plus 85 degrees, which is sine of 110 degrees. Now that's something that I don't expect you to know off the top of your head, so you would just leave that as sine of 110 degrees. So practice. Try these on your own, then we'll come back and compare answers. How'd they go? Part A, I rewrote 105 as 60 plus 45. So I had cosine of 60, cosine of 45, and I'm looking at this formula. Even though I don't mean to memorize them, I accidentally do. Cosine always has cosine, cosine, sine, sine. And if it's a plus here, it's a minus there. You don't have to memorize it. You'll have it on test day. So cosine of 60, 1/2. Cosine of 45, square root of 2 over 2. Sine of 60, square root of 3 over 2. Sine of 45. And you can check these when you're doing them at home, not on test day. If we plug in cosine of 105 degrees, I'd have to grab my other calculator. So I would have to do, let's see, this would be pi over, I'll figure it out, give me a minute. Yeah, 60 degrees is pi over 3. 45 is pi over 4, so 4 pi over 12 is 3 pi over 12 is 7 pi over 12. And yes, I went through all that arithmetic just so I didn't have to change the mode on my calculator. I could plug in cosine of 7 pi over 12, and it gives me negative square root of 6 plus square root of 2, which is exactly the same answer as I got for part A. Part B, we have sine of pi over 12. So I did 4 pi over 12 minus 3 pi over 12, which is pi over 3 minus pi over 4. And I end up with square root of 6 minus square root of 2. And yeah, you're going to see square root of 2 and square root of 6 a lot in these exact answers. And then finally, for tangent of 11 pi over 12, I wrote it as 3 pi over 12 plus 8 pi over 12, which is pi over 4 and 2 pi thirds. So you just have to use your creativity and rewrite those so that you have something that you know the exact answer for. Here's a couple where we're going in the other direction, so give those a try and then we'll compare. How'd they go? Great? Yes. So sine of 10 cosine 80 plus cosine 10 sine 80. I looked for the one that had sine, cosine, cosine, sine with a plus sign, and that was sine of A plus B. So sine of 90 degrees, which is 1. Second one, I had pi over 18. Actually, I had cosine, cosine with a minus sign. So I looked up here, I found cosine, 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 sine, sine with a minus sign. That meant it was cosine of A plus B. Yeah, I didn't feel like rewriting the whole problem over again, so I just did cosine of A plus B is cosine of 6 pi over 18, which is cosine of pi over 3, which is a half. So, determining sum and difference for unknown angles. So this is a little different. These aren't special angles where we're just plugging things in. These are ones where we're going to have to use some other techniques to figure out our sine and cosine. And let's see, we have sine of alpha and we have cosine of beta. So what I would like to do is figure out cosine of alpha and sine of beta, and then I can use those to find tangent of alpha and beta. So this is a job for our Pythagorean identity. See, example 2. So I'm going to start with alpha. I have sine of alpha is equal to 7 over 25. And I know that alpha is between pi halves and pi. Since alpha is between pi halves and pi, sine is positive, but cosine and tangent will both be negative. So I know that sine squared, so 7 over 25 squared, plus cosine squared of alpha is equal to 1. So cosine squared of alpha is equal to 1 minus 49 over 25 squared. I should know this. 625, I believe. 25 squared, 625. How about that? So cosine squared of alpha is equal to 625 minus 49, 576 over 625. So cosine of alpha is equal to plus or minus the square root of that. So let's see what the square root of is 24 over 25. And since we know that cosine is negative in quadrant 2, that means that sine is 7 over 25. Cosine of alpha is negative 24 over 25. And tangent of alpha is sine over cosine, so negative 7 over 24. Because remember, the over 25s will just cancel, and you'll end up with 7 over 24. Now let's look at beta. We have that cosine of beta is equal to negative 5 over 13, and pi is less than beta is less than 3 pi halves. That's quadrant 3. So sine is less than 0, and tangent is greater than 0, because cosine and sine are both negative. They have the same sign. So negative 5 over 13 squared would be 25 over 169 plus sine squared of beta is equal to 1. So sine squared of beta is equal to 1 minus 25 over 169. 169 minus 25 is 144. Yep, that's what I thought. 144 over 169. So that means sine of beta is equal to plus or minus the square root of 144 over 169, which is plus or minus 12 over 13. Sine of beta is negative 12 over 13, and tangent of beta is positive because it's a negative over a negative, 12 over 5, because the 13s will cancel. So now I have everything I need. Cosine of alpha minus beta is equal to, there's the cosine. Cosine of alpha minus beta is cosine alpha. Cosine alpha times cosine beta plus sine alpha times sine beta. Now, if this were a test question on test number 2 where you can't use your calculator, I would be okay with you leaving it just like this. If it's a homework problem, then I would like you to go ahead and simplify it, because it's not that hard. You already have a common denominator. So we would have 24 times 5, which is 120. Negative times a negative gives me a positive. This one's going to be negative, so negative 12 times 7 gives me minus 84, living on top of 25 times 13, which is 325. 120 minus 84, 36 over 325. So, test day, when you're not allowed a calculator, I would let you leave it like this because I don't want you taking your time doing arithmetic on the edge of the page. Homework problems, I would expect you to use your calculator and get an answer. Part B, we have tan of alpha plus beta. So that would be tan of alpha. Tan of alpha was negative 7 over 24, plus tan of beta, which is 12 over 5, divided by 1 minus negative 7 over 24 times 12 over 5. Now, I would probably just multiply numerator and denominator by the common denominator, which means I would multiply negative 7 times 5, so negative 35, and I would multiply 12 by 24. I can't do that in my head. 12 times 24 is 288. 5 times 24 is 120. Minus minus gives me plus, and 7 times 12 is 84. So 288 minus 35 is 253. On top of 120 plus 84 is 204. Let's see how we did. There's the pretty answer, 36 over 325. There's the pretty answer, 253 over 204. And you notice on here, I went ahead and got a common denominator in the numerator, common denominator in the denominator. Okay, your turn. Give these a try. Then we'll come back and compare answers. So how did that practice go? I started with alpha. Sine of alpha was 3 over 5, and alpha lives in quadrant 1, so everybody's positive. So it ended up being the 3, 4, 5 triangle. I have 3/5 squared plus cosine squared is 1. So cosine squared is 16 over 25. Cosine is 4 over 5. Tangent is sine over cosine 3/4. And then I did beta. Cosine of beta was negative 5 over 13. And since beta was between pi and 3 pi halves, that's in quadrant 3. So sine is negative, but tangent is positive. So 25 over 169 plus sine squared is 1. 144 over 169. Yeah, I made them pretty. It's okay. So sine was negative 12 over 13, and tangent was 12 over 5. Negative over negative is positive. So sine of alpha plus beta is sine of alpha times cosine of beta, and you get to use your formula sheet. So sine, cosine plus cosine, sine. So plus cosine of beta, sine of alpha. And let's see, cosine of alpha, sine of beta. Yes, there we go. Now I have it correct. And then we just did the arithmetic. Cosine of alpha plus beta, again, It is cosine, cosine minus sine, sine. So cosine, cosine minus sine, sine, negative 13 over 12. So again, arithmetic. Then I did tangent of alpha plus beta, and I was silly. I used the formula, and then I realized I could have just looked at sine negative 63 over 65 over cosine 16 over 65 and gotten the answer. And then I did tangent of alpha minus beta, so tangent of alpha minus tangent of beta divided by 1 plus tangent of alpha times tangent of beta, and I got negative 33 over 56. Okay, so let's try some that are a little different. We have some inverse trig thrown in here. So we want to find the exact values again. Oops, let's label it practice 4. Cosine of inverse tangent of 1. So cosine of the inverse tangent of 1 is pi over 4 minus the inverse tangent of negative square root of 3 over 2. And the inverse tangent of negative square root of 3 over 2, remember, inverse sine, lives on the right-hand side of the unit circle. So it would be negative square root of 3 over 2. So it would be negative pi over 3. So this is really cosine of pi over 4 plus pi over 3, which is cosine of pi over 4 cosine pi over 3 minus sine pi over 4 sine pi over 3, which would be square root of 2 over 2 times 1/2 minus square root of 2, I know it's going to be over 4, times square root of 3 over 2, which is just square root of 2 minus square root of 6 over 4. Now try part B on your own, and we'll come back and compare answers on that one. Okay, you may have struggled with this one some. The 1/2 was easy because the inverse cosine of 1/2 is just pi over 3, and we know that. Inverse sine of 3/5. Well, if we do sine of inverse sine of 3/5, it's just going to be 3/5 because 3/5 lives between -1 and 1, so it's easy. But if we look at, let alpha be equal to the angle whose sine is 3/5, then sine of alpha is equal to 3/5. That means cosine of alpha has to be equal to 4/5, because if the inverse sine of 3/5 lives in quadrant 1 because it's positive, and answers for inverse sine are always in quadrant 1 or quadrant 4, so if it's positive, then it's in quadrant 1. So that one took a little bit of work. So we have sine of pi over 3, which is easy. Cosine of inverse sine of 3 over 5 means inverse cosine, or cosine of this alpha here, is equal to inverse sine of 3/5, so it's 4/5. Then cosine of pi over 3, and then sine of inverse sine of 3/5 is just 3/5. So you had to really work at that one. Let's verify some identities. And again, we get to use our formula sheet for these. So sine of alpha plus beta, and this is example 3a. Example 3. And I have it called example 3a. Yeah, and there's the solution. So, yeah, this is A and B actually. Sine of alpha plus beta. So we'll start with the more complicated side. Sine of alpha minus beta. So alpha plus beta would be sine alpha cosine beta plus cosine alpha sine beta. And now alpha minus beta is going to be plus sine alpha cosine beta minus cosine alpha sine beta. So looks like I have two sine cosines, sine alpha cosine betas, and then I have a plus cosine alpha sine beta minus a cosine alpha sine beta, and look at that, it's exactly what I wanted it to be. I get to put the happy check mark next to it. And let's see, this was A. Let's look at B. And again, I'm going to start with the more complicated side first. And I think on this one, I'm going to start with tangent of alpha minus tangent of beta. Tangent of alpha minus tangent of beta. Because that way I can write tangent of alpha as sine alpha over cosine alpha minus sine beta over cosine beta. And now I'm going to get a common denominator. So I have to multiply this one by cosine beta. So I end up with sine alpha cosine beta minus sine beta times cosine alpha. All of that living on top of cosine alpha minus cosine beta. Now I have sine alpha cosine beta, sine alpha cosine beta minus cosine alpha sine beta, and since I can multiply in either direction, this is really just sine of alpha minus beta on top of cosine of alpha minus cosine of beta. And look at that, it's exactly what I wanted. I get to put the happy check mark next to it, but I have to neaten up that cosine. And let's see, here's the pretty answers. Okay, so when I did it this way, I did it in the other direction. I started with sine of alpha minus beta. I simplified sine of alpha cosine beta minus cosine alpha. Then I divided it into two pieces, and that worked as well. So you could do it either way you wanted to. Here's some identities. Verity, the identities. I'll fix that before I post it for you. So practice, then we'll come back and compare answers. Okay, these weren't bad. You just had to recognize that it works the same if it's a pi or a theta. And then if it's a pi, you know what tangent of pi is. It's sine over cosine, so it's 0, because 0 over negative 1 is 0. And then you have 1 plus 0 times tangent of theta. So 1 plus 0, so negative tan theta. Easy enough. Secant of pi halves plus x is the same as 1 over cosine of pi halves plus x. So 1 over cosine of pi halves cosine x minus sine of pi halves sine x. The cosine of pi halves is 0, so you end up with just negative 1 over sine, which is cosecant. So, just have to be able to use these. You don't have to memorize them. You got this.